Today we're going to study a couple different ways to represent data in a way that is quickly and easily absorbed by the reader. And those are histograms and stem and leaf plots. A histogram is simply a bar graph with no space between the bars. This is an example of a histogram. Now, what would be an advantage of a histogram over a regular bar graph? Well, it's easier to see the difference or the changes between two categories because the line, since the bars are right, it's easier to see an increase or a decrease in how much it does that in a histogram versus a stem and leaf plot or versus a regular bar graph. But really, that's all it is. A histogram is just a bar graph that's all the bars have been pushed together. This right here, that is a frequency table. On the left, you would have your group for each category, you know, for its number of sit-ups, and then we have a range for that. And then on the right, you would have your frequency, how often somebody or something met that group. You can do it either by number or by just tally marks. So I could do it number 8 or 8 tally marks. That's up to you. But on your mid-chapter quiz, you have to create a frequency table like this. Now, what do you do with a frequency table? You can then use the frequency table to do a histogram. So we're going to make a histogram. A gym teacher tested the number of sit-ups students in 2 classes could do in 1 minute. The results are shown here. Now, the reason we would have both of these, we'll see on the next page, there are some questions relating to these. And some of these questions will be easier to get the information from the frequency table. Some are more easily pulled from a histogram. All right, so we're going to make a histogram. All right, and we have to title the histogram. What might we title this? Number of sit-ups in 1 minute? Sit-up frequency, okay, that works for me. Sit-up frequency. Or sit-ups. All right, we have to label our 2 axes, correct? The bottom here, this would be the number of sit-ups, correct? And over here would be the frequency. How many people are doing these number of sit-ups? Now, what I want to do when I create these is I want to do the bars, and I want them, they're going to be close to each other and 1 for each one of these groups. Well, frequency, I have to go all the way up to 30, correct? Because here's 29, here's 0. So my frequency is going to go from 0 to 30. How do you think I might break those up easily? Could I go up by 2? Could I go up by 2? Yeah. What seems to be more logical, though, by 5s, yeah. That's what I did 4th period. And that makes a lot. Could I go up by 10? Sure. That's up to you, though. Huh? No, frequency. Oh, I guess I only have to go up to 20. 5, 10, 15, 20. And then the number of sit-ups will go, 0 to 4. And then we'll let the bars have to be together. So I like to put my bars in first, and then I'll label them afterwards. All right. 0 to 4 sit-ups. How many people did those? 8. So I have my bar. It's going to go up to there. Now, what's different about this one is this. For 5 to 9, I go to 12, but look, they're connected. And this is for 5 to 9 sit-ups. The next one's going to be 10 to 12. And it's 14, which is up just a little bit higher. And the next one's going to be 15 to 19. And that is down to 6. Kids need to get off the couch. And 20 to 24 is my next group. And that is 18. And the last one, 25 to 29, and that is 10. As you can see, I didn't leave any lines in between there. Well, now we can see the same data two different ways. All right, we have some questions to answer. How many students were able to do 25 to 29 sit-ups in 1 minute? Which one might be easier to see that? The frequency table or the histogram? Frequency table, correct. And how many did it? 10. How many students were unable to do 10 sit-ups in 1 minute? Yeah, that is. You probably did this at your school, right? Yeah. Okay. And you were in the... No. Okay, that's what I'm saying. How many were in the first, were unable to do 10? What might be easier to use, the histogram or the frequency table? I would think the frequency table, you could use that one. And how many couldn't do? 20, right? Here's 8 here and 12 here. That's 20 total between the two. I'm going to add those two up. So 20. Between which two consecutive intervals does the greatest increase occur? Which one's going to be easier to see that? The histogram or the frequency table? Histogram. That's what the bars do. You can see where the biggest jump is. So we want to see between which two consecutive intervals does the greatest increase occur, and then we'll use what to find out the increase? Frequency table to find the increase. All right, between which two? Yeah, here's the biggest jump right here between those two intervals. And it's 15 to 19 and 20 to 24. So 15 to 19 and 20 to 24 right here. What is the jump? 12. Yep, 18 minus 6 gives you 12 right there. So that's the jump. So 15 to 19, the greatest increase is from 15 to 19 to 20 to 24, and it increased by 12. So that's where we're pairing those two together to quickly and easily get that information and digest it and move along. The other way we can quickly assimilate information is through the use of a stem and leaf plot. Stem and leaf plot is a fast and efficient way to organize data for easy interpretation of the data. Here's what I mean. You can list a bunch of numbers in a very small space. There are a bunch of numbers, they're not in a small space. But we could list those bunch of numbers in a small space using a stem and leaf plot. The stem is usually the digits in the tens place or the tens in the hundreds place. And then the leaves are there the digits in the ones place. Now one thing that I don't have here. Alan, do I got to make one for you too? I think I do. You're on, I've given you notice, sir. The one thing I didn't include here is that under every stem and leaf plot you have to have a representation key. Like this, for this one, it could be 1/1 represents 11. So we know what the number in the stem represent, or numbers in the stem represent, and what the number in the leaf represents. We can also use a stem and leaf plot to pick out characteristics of the data set. Some of the characteristics we can pick out are clusters. Clusters are just isolated groups of values. It's a lot of numbers compacted. You will see a cluster if there are a lot of the same digits in the leaf and they're right next to each other. So you'll have maybe 3 5s, a couple 6s, 3 7s, and an 8. That would be a cluster. You're going to have them all together. Gaps. There are large spaces between the values. So it might jump from 22 to 35. That would be a gap. And then outliers are data values that are much greater than or much less than the other values. Now these typically occur just at the beginning and just at the end of the numbers. If I put them in numerical order, they would be at the very top of the stem or the very bottom. I'll give you examples. The example we're going to have doesn't have any outliers, but I can give you examples of what an outlier would be from that. Or the Weather Bureau in Baltimore, Maryland recorded these daily high temperatures in Fahrenheit for the month of November. So what we're going to do is we're going to make a stem and leaf plot of that data. Now when you make a stem and leaf plot, you can either do it with just one vertical line. I prefer to also have one up here. I don't know why, it just makes it look more like a table to me. But you don't have to. Oh, great. So I'm going to make this. First thing I got to figure out is what are my range of numbers? What's the smallest one and what's the largest one? What's the smallest number up there? 22. What's the largest? 54. So in the stem, what numbers do I need to have here in the stem? 2, 3, 4, and 5. That's right. For the 20s, the 30s, the 40s, and the 50s. And I can make my guide right now where 2/2 represents 22. Now I'm just going to start listing those numbers. I like to do it in numerical order, but I have seen the stems, the leaves, where they have not been in numerical order. Nope. It's preferable. Depends on how picky your teacher is. If it's in numerical order, it's easier to grade. But no, I've seen them not in numerical order. Now I'm going to write all the numbers in the one place. First, I'll start with the 20s. 22, there's a 2. 5. Yeah, there's 26. How many 29s are there? 2? 9. 9. Is that it? Yeah, I told you it wasn't. 30. Is there a 30? Okay, so I have 130. 31. Now, notice how I'm lining up the 0 under the 2 and the 1 under the 5, so I have nice columns when I'm done. Did I cross off the 30? 31. 33. 3 times, yes. 1, 2. There's more than 136, I think, isn't there? Maybe not. No, there's more than 146. 36, 6, 37. Bless you. 39, 39. And I believe that's it for the 30s. Now on to 40s. I have 1, 2 40s. 0 and 0. Is there a 42 there? Okay. 42. 44, 44. So 2 44s. 2 45s. Oops. A 46. Is there another one? Up, left. Another 46. 48 here in the middle. All right, now for the 5s. A 50. 51. 52. 54. All right. Oh, is there 2 of them? Oh, yes, you're right. Very good. 2 52s. Good eyes. Now, what I can do now is I could take this, because it's in a stem and leaf plot, and quickly look at this and figure out what numbers I have. Are there any clusters? A cluster is a big group of numbers. Yes. That's a cluster. And you'll find a cluster by a bunch of the numbers in the ones places, and the leaves will be repeated, and they're close together. Here's another one. There's another cluster. Any gaps? There is a... Not really. There's a small gap between 22 and 25, but it's not really much of one. An outlier would be this. If I had this number and then I had like the number 80, so if I had 80, that would be an outlier because it's so much greater than 54. An outlier is anything where you might skip 1 or 2 numbers in the stem, in the tens place. All right? But that's what we can do with the stem and leaf plot. We can quickly identify gaps and certain values within our data. All right. Any questions? By the way, that was your last lesson of the year. 1 to 16 all, pages 18 and 19. I am done teaching you math this year. Elvis has left the building.